So this is our intro to machines. A machine is ultimately going to be any device that makes work easier, and that sort of makes sense. If you think about the machines that you use in your everyday life, we typically have them to make our work easier. And what machines will do is they will increase the force applied to the object without actually increasing the work done. So you can get, have like more force applied to the object with the same amount of work. A simple machine is basically going to be any device that changes the amount of force or the direction of the force applied to an object. And it does work with only one movement of the machine, not multiple different movements. So we're going to talk about 6 basic simple machines. The first one is going to be a lever. And you've sort of seen levers before, and this is probably a simple lever right here. Another machine that we're going to talk about is an inclined plane, also known as a ramp. We will also talk about pulleys. So I'm sure you've seen a pulley system before. See, there's a weight on that end. And what else? We have a wedge, which is going to sort of look like 2 inclined planes together. We will have a, a wheel and axle. I can't remember, is it axle? I want to say it's axle. Yeah, that looks better. And that'll look like this. And last but not least, we have a screw. And we'll talk a little bit about that as well. But the big ones that we're going to be focusing on for our class is going to be a lever and an inclined plane. When we talk about these, we're going to be talking about ideal mechanical advantage with these, but I want to talk about actual mechanical advantage, which is basically going to be the ratio of the input force to the output force. But it does it with the output force on top and the input force on the bottom. And of course, the input force is going to be the force applied to the machine, while the output force is what is being applied by the machine on the object that we are trying to do work on. And also, for real machines, some of the energy that's put into machine is always converted to heat by frictional forces, and we know that frictional forces exist in most regular scenarios. And so efficiency is basically going to be a measure of how much of the work that is actually put into the machine is changed into useful output work by that machine. So I want to know how much of the work that I actually put in went towards doing work on the actual object. And so we can calculate that, and efficiency will be basically a percentage. Like, is it 90% efficient? Is it 80% efficient? And we're going to calculate that by basically having the output work divided by the input work multiplied by 100%. And so a machine with really high efficiency therefore produces less heat, because most of the work going in towards it goes towards the output work. A machine with therefore lower efficiency would have lots of heat being produced, and an ideal machine would have output work equaling input work. And so when we talk about ideal mechanical advantages, we're talking about if this machine was ideal, what would it be like?